Good morning, good evening, good afternoon, wherever you may be watching this from. This is Cornelius Binda with another segment of vectors. Now, today we're going to look at the scalar or dot product of two vectors. So we can have vector A and vector B. And I've told you to find the scalar or the dot product of those two vectors. There's one thing to note before we get on with the video. In A-levels or under A-level studying, we'll look at the vector product of two vectors. So the vector product is not covered in under additional mathematics. We only cover the scalar or dot product of two vectors. I'm going to talk about the formula for finding the scalar or dot product of two vectors. And then, like I said in prior videos, examples of all these subtopics that we have looked at will be covered in later videos. Why I do this is because I do not want to make the videos too lengthy, like the first two videos that I posted. Okay. So scalar or dot product of two vectors, it is given by the formula if we have two vectors. So if we have two vectors, we have two vectors, that is vector A and vector B. And then we are told to find the scalar or the dot product. It is given by A, vector A dot B is equal to magnitude of vector A multiplied by magnitude of vector B multiplied by cosine theta or theta. So why do we say dot product? The dot product comes from the formula. There's a dot there. This dot means multiplication. A dot B, vector A dot vector B is equal to magnitude of vector A. You multiply by magnitude of vector B. You multiply by cosine theta. And now if we got the parent graph of a cosine wave is positive from 0 to 90 degrees. It is positive. And then 180 degrees. Yes. All the way. Because the cosine wave will come down at 90 degrees. So 90 degrees actually, 90 degrees to 270 degrees, it is negative. Because it crowns there. It crowns there. So 90 degrees to 270 degrees, it is negative. What am I trying to say? All those things that I've said. I'm trying to say that from 0 degrees to 90 degrees, if I've been given a theta like that, we are going to have a positive dot product. From 90 degrees to 270 degrees, you're going to have a negative dot product. From 270 degrees to 360 degrees, you're going to have a positive dot product. Alright, upon us knowing that, what we're trying to say is the dot product, it is always a number. It will never be anything, it is always a number. It should always yield something. So there are four main things that you need to note about a dot product. The first thing about the dot product is it is commutative. What do we mean? A dot vector B is equal to vector B dot vector A. Commutative, it means that these vectors can change. You can swap them. You can start with vector A times vector B or vector B times vector A. They are commutative. That's the first thing we need to note. And then we have parallel vectors. Parallel vectors. Parallel vectors. What should we say under parallel? So vectors can be parallel, like we said in prior videos. They can be parallel in the same direction. They can be parallel in opposite directions. Now, if they are parallel and in the same direction, theta is equal to 0 degrees. So they are parallel in the same direction. Two vectors, vector A, vector B. Theta is equal to 0 degrees. So there's something we need to know. Cosine of 0 is 1. Be very careful. So if they are parallel and in the same direction, theta is equal to 0 degrees, like in this example. Now, if they are parallel and in opposite directions, so we can have this vector vector B, negative of vector B. These two are parallel and in opposite direction. Another thing you need to notice is that they have the same length. So two vectors, they are parallel in opposite directions. Theta will be equal to 180 degrees. 180 degrees. Which means we know cosine 180 degrees from the parent wave is -1. It is negative because the cosine wave goes like that, like this. Then there, at its lowest point, it is -1. 180 degrees. That's how a cosine wave is. So, if they are parallel and in the same direction, theta is equal to 0 degrees. If they are parallel and in opposite direction, theta is equal to 180 degrees. Then the third thing to know is vectors, perpendicular vectors. The dot product. So if two vectors are perpendicular, A dot vector B are perpendicular. Perpendicular means they at 90 degrees there. That's what I'm trying to say. We meet at 90 degrees. Then the dot product. Alright? Let me repeat that. A and B are perpendicular. Then A, vector A dot vector B, it is equal to 0. If two vectors are perpendicular, their dot product is equal to 0. This, why is it like that? The reason being, perpendicular vectors, it means they meet at 108, or the angle between the vectors is the angle between the vectors is 90 degrees. So cosine 90 degrees following the cosine wave is equal to 0. Now, if we have if we have here in our formula cos 90, the value of cos 90 is 0. So it means 0 times everything here is 0. If two vectors are perpendicular, the angle between them means it is 90 degrees and the dot product A dot B is equal to 0. That is for perpendicular vectors. Always remember this. As we come to the examples, this would be very important. I times I, J times J is equal to 1 is equal to 1. I times J is equal to 0. I times J is equal to 0. That's a very important point to take note of. I times J is equal to 0. This will be very important to find the dot product when we come to looking at examples. So the fourth rule is that the dot product is associative. Dot product is or vector multiplication of vectors. It is associative. When you're multiplying vectors, it is associative. What am I trying to say? If we have vector A, vector B plus C, if they tell you to simplify something like this, now if we go back to our normal algebra, A and then B plus C will be AB plus AC, like that. That is our normal algebra. Vectors also follow this rule of association. It means that it will be equal to vector A of, sorry, this marker is not okay. It will be equal to vector A, vector B plus vector A, vector C. So same answer as this. So we have explained the dot product and the rules to follow under the dot product or the scalar product of two vectors. This has been Cornelius Lubinda with another segment, and until the next video, bye bye.